Skydivers and wingsuit flyers may call what they do free falling, but as you may have noticed by now, in physics, words mean something a little more specific. So let's explore what free fall is all about in this segment of Physics in Motion. Free fall is what an object does when it is under the influence of only one force, gravity. We have to go way back in history to get a handle on why this matters, but we'll keep it short. For thousands of years, scientists thought that how fast something fell depended on how heavy it was. Seemed only logical. But in the 16th century, one of the all-time Science Hall of Fame geniuses, Galileo, had an idea. He suspected that all objects, regardless of their mass, fell at the same rate of acceleration. If he were to take two objects, one light and the other heavy, and drop them from a height, they would both hit the ground at the same time. This showed that acceleration is independent of mass. Let's go try this ourselves. So between this watermelon and this cantaloupe, which do you think will hit the ground first? Both hit at the same time. The watermelon made a bigger mess, but as far as acceleration goes, we verified Galileo's point. It even works on the moon. Take a look at this clip from Apollo 15. The gravity on the moon, even though it's less than that of Earth, still made the feather and hammer drop at the same rate of acceleration. Gravity, in fact, is one of the most important forces in the universe. So back to the 16th century. When people realized that objects behaved this way, it was a major turning point in understanding how the universe works and being able to predict how things will move. Galileo, using the instruments available to him, measured the acceleration that was due to gravity on Earth, no matter what the object, at about 10 meters per second squared. We now know it is 9.8 meters per second squared near the surface of the Earth, so he wasn't far off, which is impressive considering he used his heart rate as a timer. That is the constant rate on Earth that the force of gravity accelerates everything. All objects, regardless of their mass, fall at the same rate, 9.8 meters per second squared. But, you say, what about air resistance? And you're right. But let's put other factors aside for right now, since we're only concerned with how things work in free fall. We'll get to those in another video. Now, let's look at a free fall problem together. Let's say that we throw a ball upwards. What is the ball's maximum height? And why is that a free fall problem? Because technically, an object is in free fall even when moving upwards or instantaneously at rest at the top of its motion. Because, remember, free fall means that gravity is the only force acting on an object. We can use some of the variables we know to plug into an equation to solve the problem. The origin is the place the ball left our hand, and the positive direction is up. Let's say I throw the ball at 10 meters per second up in the positive direction. I want to find out what my ball's maximum height will be before it starts falling down. There are steps we can follow anytime we solve problems that involve kinematic equations. Step 1 is to write down your variables. The ball's initial velocity would be positive 10 meters per second because it's traveling up in the positive direction. But when the ball leaves my hand, it immediately starts to decelerate because it is only under the influence of the force of gravity. The ball's acceleration, a sub g, is negative 9.8 meters per second squared because when it is decelerating, its initial velocity and acceleration have opposite signs. We are slowing down in the positive direction. It decelerates until it reaches a velocity of 0 at its maximum height in its travel, and that's v sub top. We now have values for our initial velocity, final velocity, and acceleration. Our unknown is our maximum height, which we represent as d, displacement. The next step is find one of the 4 equations you can see here that has the 3 variables that we know and has our unknown variable, all within the same equation. We should use equation number 2. Final velocity squared equals initial velocity squared plus 2 times our acceleration times displacement. Now, let's do step 3, plugging in all of the variables that we know, along with a symbol d, representing the thing we are solving for, displacement. Our final velocity is 0 meters per second and it is squared. This is equal to 10 meters per second squared plus 2 times negative 9.8 times the displacement. In the final step, step 4, we solve for the unknown, displacement. We get rid of the exponents by squaring the numbers and units within parentheses. 0 squared is 0, and 10 squared is 100. Then, subtract 100 from both sides, which leaves us with the equation negative 100 meters squared per second squared equals negative 19.6 meters per second squared times our displacement. We need to get displacement alone, so we divide both sides by 19.6. This gives us a displacement of 5.1 meters. That's how far my throw traveled in free fall before it reached its maximum height of 5.1 meters. Here's a bonus question for you. At what velocity will it reach my hand when it falls back down? It will be the same speed that it left my hand to begin with, 10 meters per second. Except this time, the velocity will be negative 10 meters per second because the ball is going in the opposite direction. The rate gravity slows the ball going up is the same rate it speeds it up going down. So now you know that free fall in physics is when an object is only under the influence of one force, gravity. That's all for this segment of Physics in Motion. We'll see you next time.
For more practice problems, lab activities, and note-taking guides, check out the Physics in Motion Toolkit.